So in this video, dear students, we will be solving questions on shortest distance between skew lines, right? So the first line is of the form x plus 1 by alpha is equals to y minus 2 by minus 1 is equals to z minus 4 by minus alpha. Let the fixed point through which the line is passing, I'm taking it as point A or vector A, right? Which is minus I cap plus 2j cap, or let me write it as point A. Point A is minus 1 comma 2 comma 4, and the direction of this line, let me write it as B. Okay, direction ratios will be alpha minus 1 minus alpha, and similarly for L2, let me write it as x divided by alpha is equals to y minus 1 by 2 is equals to z minus 1 by 2 alpha. This is a frequently asked question, dear students, so directly I'm assuming that you know the concept. So point C will be 0 comma 1 comma 1, and point D will be, direction of this line will be D, which is alpha comma 2 alpha, right? And so he has given the shortest distance as root 2. So what is the formula? Shortest distance between the skew lines will be mod of box C minus A B D, right, divided by mod P cross D, right, vector B, right? So point B is nothing but the position vector of B with respect to origin, that is OB vector, which is alpha I cap minus j cap minus alpha k cap, and OD vector is alpha I cap plus 2 j cap plus 2 alpha k cap, right? So shortest distance is root 2. So we will first find the numerator. So numerator is C minus A BD. So box of this is nothing but determinant, dear students. So in the first row we will find OC minus OA, that should be 0 minus of minus 1. Next 1 minus 2 is minus 1, 1 minus 4 is minus 3. In the second row we will write the position vectors of B with respect to origin, that is alpha minus 1 minus alpha. In the third row we'll write position vector of D, so that should be alpha 2 alpha, right? So if I expand the determinant along the first row, we get 1 into minus 2 alpha plus 2 alpha, and minus of minus 1 is plus 1 into 2 alpha square plus alpha square. I hope you know how to expand the determinant. Then we get minus 3 times 2 alpha plus alpha. So ultimately we get 3 alpha square minus 3 into 3 alpha, that is minus 9 alpha. Perfect. And then we will now find B cross D. So that will be I J K. I hope you know how to find cross product. So position vector of B is alpha I cap minus j cap minus alpha k cap. So we'll write alpha minus 1 minus alpha, and then we write here D, position vector of D, that is alpha 2 alpha. So we get I cap into, we have to take the magnitude of this. So this is B cross D firstly. So this will be I cap into minus 2 alpha plus 2 alpha minus j cap into 2 alpha square plus alpha square plus k cap into 2 alpha plus alpha. So we get this as 0 I cap minus 3 alpha square j cap plus 3 alpha k cap. So this is B cross D vector. Magnitude of this will be under root of minus 3 alpha square whole square plus 3 alpha whole square. So we get this as under root 9 alpha power 4 plus 9 alpha square. So we can take 9 alpha square common. So if I take 9 alpha square common, it will be remaining with the alpha square plus 1. So this will be nothing but mod 3 alpha into under root alpha square plus 1, right? So ultimately now shortest distance I think is root 2. So we can write root 2 is equal to modulus of, what do we have in the numerator? 3 alpha square minus 9 alpha, and in the denominator we have 3 alpha into under root 1 plus alpha square within modulus, right? So in the numerator again we can take a 3 alpha common. So we'll be remaining with alpha minus 3 by 3 alpha into under root alpha square plus 1. So we can cancel this. Now I think what is he asking here? He's asking us to find the sum of all values of alpha, right? So we'll do one thing, we'll cross multiply. For the denominator we can remove modulus because square root is anyways positive. So we have mod alpha minus 3 here. Now we'll square on both sides. We get 2 times 1 plus alpha square is equals to alpha square plus 9 minus 6 alpha. So we get 2 plus 2 alpha square is equals to alpha square minus 6 alpha plus 9. So ultimately we get alpha square plus 6 alpha minus 7 equals to 0. So he's asking us to find the values of sigma alpha I. So let us say alpha 1 and alpha 2 are the roots of these equations. He's asking us to find the sum of the roots. That should be minus 6, I think. Yeah. Okay. Sum of all values of lambda alpha for which the shortest distance. Okay. Is there any error? Okay. So I think, this should be Yeah, so it should be minus 6, right? Minus 6, minus 6. Yeah, okay, perfect. Option 4 is correct. Now let us go to the next question, dear students. Next question says, let P be the point on the line, perfect, at a distance of 4 root 14 from the point and nearer to the origin, then the shortest distance. Okay, so first let us try to solve this part of the question. P be a point on this line at a distance of 4 root 14. So we will take a point P in terms of lambda. We will equate this to lambda. So we can write a general point as 2 lambda plus 1, comma, minus 3 lambda minus 1, comma, lambda. Acha, distance of this point from the point 1, comma, minus 1, comma, 0. Okay. Let P be the point on this line at a distance of 4 root 14 from the point. Yeah, acha, and one more interesting thing is this point also lies on this line. Right, how do we know that? Replace x with 1, we get 1 minus 1 is 0. And replace y with minus 1, we get minus 1 plus 1 is 0. And z with 0. So that means, okay, this point also, this point is somewhere here. That is 1, comma, minus 1, comma, 0. And the distance, let us say this is A and this is B. The distance between A and B is, I think, 4 root 14. Now, okay, that point also, acha, P should be nearer to the origin. Okay, fine. So we'll do one thing. Now everything is in terms of lambda. So we will do one thing. Let us square on both sides. AB whole square should be equals to 4 square is 16 into 14. Okay. Now AB whole square should be 2 lambda plus 1 minus 1 is 2 lambda whole square minus 3 lambda minus 1 plus 1 is minus 3 lambda whole square. Then lambda whole square should be 16 into 14. So if I expand this, I get that means we can write lambda is equals to plus or minus 4. Now A or whatever, A or P could be, A could be, acha, lambda could be plus 4 or minus 4. If I take lambda as plus 4, I get A as, let us say, A1. That will be 2 into 4, 8 plus 1 is 9, comma, minus 3 into 4 is minus 12, minus 1 is minus 13, and this should be 4, right? And A2, if I take lambda as minus 4, I get 2 into minus 4 as minus 8 plus 1 is minus 7. Minus 3 into minus 4 is plus 12 minus 1 is 11. And then I get minus 4 here. Now, acha, point P should be closer to the origin, nearer to the origin. That means, let us find OA1 distance. That should be, acha, coordinates of origin are 0, 0, 0, dear students. So, 9 minus 0 is 9. 9 whole square is 81. Minus 13 minus 0 is minus 13, whole square is 116, 9 plus 4 minus 0 is 4, 4 square is 16. So 81 plus 169 is 80 plus 170, I believe. 170 plus 80 should be 250. 250 plus 16 should be 266 if I am right. Yeah, and now we will find OA2. That should be I think minus 7 whole square is 49 plus 11 square is 121 plus minus 4 whole square is 16. So 121 plus 49 is 50 plus 120, that is 170. 170 plus 16 is I think 186 if I am right. Acha, point P should be closer to the origin. That means this is the coordinates of P, right? So point P has the coordinates of, or A2 basically, which is minus 7, 11, minus 4, because this distance is lesser than this distance. That means root 186 is less than root 266. So ultimately, then I think we can, now I think we can find the shortest distance between the lines. So first L1 is passing through alpha, beta, gamma, and has direction ratios as 1, 2, 3. That means, now let me take position vector as A bar is equals to alpha, beta, gamma. And what is alpha, beta, gamma? That is minus 7, 11. So dear students, this is just a notation. Actually, it should be written as minus 7 I cap plus 11 j cap plus minus 4 k cap. So for our understanding, I am writing it in this way. And direction of this line is 1, 2, 3. And then L2 is passing through minus 5, 10, 3. That means minus 5, 10, 3, right? And the direction ratios are 2, 1, 1, right? So d bar is equals to 2, 1, 1. So now shortest distance will be same thing, magnitude of C minus A BD divided by mod B cross D, right? So the numerator will be C minus A, PD, box, this will be determinant of, the first row will be C minus A, acha, minus 5 plus 7 should be 2, 10 minus 11 is minus 1, 3 plus 4 is 7. The next row will have 1, 2, 3, then 2, 1, 1. So if I expand the determinant along the first row, I get 2 into 2 minus 3 is minus 1, minus is plus, 1 minus 6 is minus 5, plus 7 into 1 minus 4 is minus 3. So we get minus 2, minus 5, minus 21, minus 7, minus 21 is minus 28. Don't get frightened with the negative sign. We have a modulus. Now we need to find B cross D vector. That will be I, J, K, and vector B has the coordinate, direction ratios as 1, 2, 3. Vector D will have 2, 1, 1. So if I expand this determinant, I get I into 2 minus 3 is minus 1, minus J into 1 minus 6 is minus 5, plus K into 1 minus 4 is minus 3. So we ultimately have minus I cap plus 5J cap minus 3K cap. This is B cross D. Now I think we can comfortably find mod B cross D. That should be under root of 1 plus 25 plus 9. I hope you know how to expand the modulus, or you know how to find the magnitude of a vector. So we get 9 plus 1 is 10, 10 plus 25 is 35. So the answer should be, shortest distance should be magnitude of, or modulus of, minus 28 by root 35. So it should be 28 by root 35. Yeah, let us see the options. Okay, options are in this way. So let us further simplify it. We can write this as 7 into 4 by root 7 into root 5. So we get 4 root 7 by root 5, or we can write it as 4 under root 7 divided by 5, right? So 4 under root 7 by 5. I think option 1 seems correct. That's it. Thank you for watching this video, dear students. Meet you with the next one.